Why is 0, 0 if they reject? 618. Oh, that's a long time ago. Uh, yeah, they reject because it's not fair. Because alpha equals 1. Right? If alpha equals 0, then like you will take any amount, right? If responders alpha equals 0, that means that responder are not feeling any pain from any amount that proposer give. So if proposer gives $0, like I don't care, right? Yeah. But anyway. Okay. Um, are we good on C? Okay. We're good. I'm just gonna keep going on D. Okay, consider an economy with two individual. Oh no, what am I reading? Now suppose the proposer does not know the responder's alpha. Could be 1 or 0 or 1 with a equal probability. Assuming the proposer is a risk neutral, determine the outcome of the automated game. Okay, so I'm just gonna borrow it. I don't want to draw it again. Um, just borrow the graph. Borrow the graph. So beautiful. Okay, so we already determined the value of S min, right? So this 1/3 is S min, and then this 0 is 0. So we're at proposer. Let's kill the I and kill the J. It's confusing. Responder and proposer. Okay, so now suppose the proposer does not know the responder's alpha. So we don't know the responder's alpha. So we know that this line right here, we know that if we offer S min, responders, well, let's say alpha of responders between 0 and 1, no matter what value this take from 0 and 1, we know that responder will accept, right? And then the only thing that will determine the only thing that the alpha will affect is when I offer 0, right? We know that if the responders has 0 alpha, we can get away with giving them 0. And then I will have an outcome of 1, 0. But if they have any alpha, they will experience this utility from the unfairness the proposer proposed, and they will reject. The responder will reject. Okay, so it looks like this. U R, which is the responder. Responders utility looks like S. Let's not use S. That's XR. Okay, minus alpha of okay, uh, XP minus XR, right? So if alpha equals 0, the responder doesn't care about inequality, right? But if there's a half a probability that this thing is one, like alpha equals to one, then I will reject your offer because I think it's unfair. I want to like you get nothing too, right? So then we just need to set this inequality and we can find the beta. So last time I was like writing some weird probability condition, but this I will write it correct. Given that s equals to 0, what's my probability of accept? And given that s equals to 0, what's my probability of reject? Right? They're all equals to 1/2. So now we can just set this two thing together and we can find the beta, which will look like u of p equals to, so if I'm giving, hmm, thinking. Yeah, if have 1/2 1 minus b plus 1/2 of what? 0 and 0, right? I mean, 0 minus 0 if for this space, right? So up if I'm giving s, is if doing s equals 0. So that's a probability space. So either I can get away with it or either I can't get away with it. All right. And then we set them equals to our definite thing, which is 1/3. No, that's estimate. 1 minus 1/3 of minus beta of. So, and then we get beta equals to -1. Any question on this?
Wait, can you backtrack and start over from that part?
Which, which part? This part?
No, this equation, the one minus 1/3. Yeah, that one, second one.
Oh, yeah, this is from here. Because the beta is the same. We need to find the critical point. So this beta beta equals to -1 means that proposer is indifferent. In giving S min or 0. So what happened if beta is less than -1? Means that proposer gains utility from gambling. Gambling other people's pain. Well, I mean, on the gambling is profit. I don't know. Like from maybe not gambling. Let's say from from taking the risk. Taking the risk of possibility of taking all the all the money all the money. Okay. So if beta is greater than -1, means that proposer will lose the utility. Uh, utility from I guess thinking about other people's because like this beta, like how do we interpret this beta again? Anyone?
It's less than a half, so they don't care about the inequality.
Uh, mm, mm, as I said, like it's not. What do you mean 1/2?
Oh, sorry,
So
that was the other part.
right, because before we have beta equals 1/2, but now we have beta equals to negative, right? So if we have a negative, that means that negative of negative beta will give us positive, right? What's beta determined? Beta determines other are poor, right? So when I have a negative of negative beta, well, I mean, not negative of negative beta, it's like double negative. Um, when we have negative beta, we enjoy to see other people's inequality, right? The more poor they are, the happier we become. I want to see them broke, right? That's what negative beta means. They gain utility from other people's pain. Others disinfortune. Is there an English word for it? Or others poverty? I don't know. My English is so bad. Yeah, if you guys can tutor me English, that would be great. Uh, okay. So any question on D? This exam so long. Okay. Um, any question?
I just had one quick question. That's okay. Negative alpha means pleasure from other people's success.
You mean negative beta right here from
No,
proposer?
no, a theoretical negative alpha.
Oh, negative alpha, it's you are happy for other people's success. right? If
Okay.
your parents or you see your siblings that they're like, or your friends, they become super successful, you're happy for them too.
Okay. Thank you.
Okay, so let's take a 5 minute break. Well, maybe 4 minutes. I'll be back. And then we can look at or can we have a vote? Should we do just question two, or should we do both?
I think we should just do question 2 from the final exam.
Because question one is easy,
Yeah, I feel question 1 was like doable.
doable, doable. Okay. Yeah, question one. You have to really be careful about how to draw the trees. Um, that's on question one, especially when you um touch D and E. I can't draw it. Ew. Anyway, you get the point. Yeah. Um, let me see. Oh, I can. Yeah. Okay. So D and E, very careful on how you draw the tree because the backward induction on this one, it's not so obvious. Yeah. Okay. After 5 minutes, I will start on question two. Um, unless you guys have anything on question one, we can go over it. But let's do question two first. Um, yeah, I just want to like have a little bit of time tonight to grade. Just make sure to get a grade back before tomorrow. Okay. Okay. I'm back. So let's start with question two. Um, okay. Question two is so long. Yeah. Okay. Let's apply Fair-Schmidt. Okay, so let's write out what Fair-Schmidt look like. So Fair-Schmidt is xi equals to, oh no, ui equals to xi minus alpha I of what again? Oh, my brain. XI. Yeah, that's fortune, right? So other people's fortune should be xj minus xi. And then we have minus beta of I of xi minus xj. So that's our Fishman. Just to write out j. Okay, so let's read the question. Suppose proposer is giving $1. $1. Okay. So $1 to proposer. They must decide how much S to send to the responder. S, responder. The responder receives 3S. So responder to receive 3S. So like the dollar sign really confused me. Like $3S? What does that mean? But anyway. So proposer is tripled, and then he then decide how much T to send back to the proposer. Yeah. Okay. That's it. Okay. So in terms of like this thing, it's basically Fishman. Like if you read through it deeply, it's just Fishman, nothing different. It's like max and min, stuff like that. Yeah. Ooh, so green. Okay. So beta of P proposer is between of 0 and 1. And alpha P is greater than beta P. The responder's reference preference can be similarly specified. Assume that the player are fully understand the rules of the game and know each other's preference. Okay, so we know each other's preference. Okay. Hey, what would the outcome of the game if the player had standard self-interest preference? Explain briefly. Okay. Anyone want to try this? What's standard self-interest preference?
The responder would give no T, so the proposer would give no S, and then no one would have anything.
Right. So self-interest. So let's go through a game tree. Well, it's not really a game tree. Is it a game tree? Can you call it a game tree? I don't know. Call it a tree. So we have a proposer and we have a responder. So proposer is giving S amount, right? So proposer can either give an S amount or 0 amount. Responder can do what? Can someone help me complete the game tree?
Accept or reject.
Okay. Accept. You sure? You sure it's accept and reject?
Um, Those are the only options.
This-
Well, there's another node beyond accept where they can also send money back. So there's a T in there.
Right. So it's not really accept and reject. It's either R, make the decision of giving T or 0. Right? If you give me the amount of S, I have to make a choice of give you T or give you 0. Right? I mean, technically it's correct, like you know, accept and reject, but you like either if you reject, like, you know, it doesn't mean anything, right? In this term, the reject means I'm not giving you any money back. Right. So what's the outcome for both scenario? Well, I mean, 3 scenario.
In the first one, the proposer would receive 1 minus S, but they
Okay,
would also gain a T.
good. What about responder?
They would get S, but they'd be sending T back. So it'd be S minus T.
3S, right?
3S minus T.
Okay. What about
Yeah.
if it's given 0 back?
Proposer would not get the T. There would just be 1 minus S. And the responder would not give T, so it'd just be 3S.
Good. What about the last one?
0, 0.
0, 0?
Proposer is sending 0, and I think, and responder is going to reject 0 because it doesn't say alpha is 0.
Okay, in this question, you have to really read this question, right? No, I mean, technically, okay. So this tree I'm building, it's not for A. It has nothing to do with A. It's not a self-interest game. Like, I'm not building that game. I'm trying to build a model for Fair-Schmidt. Right. So you will have 1 and 0. Okay. So this is our game tree. Okay. So self-interest. So of course, P want to maximize their utility, right? Maximize the amount of money they earn, right? Yeah. No. Okay. So like P would prefer, like everything, if everything works well, like this should be the optimal outcome. Right? But P does not know whether or not R's decision between whatever, right? So in R's perspective, R have to pick between 3S minus T or 3S. What will R pick?
Are we on A or B?
I'm trying to just go through this like really simply, and then we can go to B.
Oh, okay. Sorry, I misunderstood that.
Yeah. Like in this case, if you are like self-interest, right? If you purely self-interest, you will pick 3S rather than 3S minus T, right? Yeah. So in pure self-interest case, you will pick something. Pick this thing. So this thing is out, right? Okay. Now let's look at proposer. What will proposer do in this case? If proposer know that this outcome is not happening, And then proposer have to compare 1 minus S and 1. Proposer will not give anything, right? So proposer will rather choose this than this. So that's the self-interest game. Like really simple intuition in the game tree. Well, I mean, in the tree, decision tree, not game tree. I don't even know what game tree looks like. Okay, so that's for A. Okay, so let's go B, because we're gonna use the same graph again. It's gonna show up everywhere. B. Now use backward induction to predict the outcome under Fishmidt's preference. Suppose the proposer has picked some value of S, and now the responder has a 3S and has to choose a value of T. Observe that the responder would consider sending the money back only if it helped to narrow the gap between himself and the proposer. What would the value of S would this be the case? Okay, so how can we set it up?
It's an edge case where we have to figure out the point at which the responder is indifferent between sending and not sending, I think.
Responder between sending and, well, between some level of T and responder for 0? Something like that?
Yeah, something like that.
It's actually a little bit more simpler than that. So here, let's take a look at this. If 3S is less than 1 minus S, what will happen? Let's think about the model. Let me just clean it up. What if you are receiving less than your proposal? Because like when proposers send me the money, right? Like for example, you and me, Zach, you send me money, and you send me some like dismal amount of money, even though I got triple, but I'm still less than you. In this case, what happened? Just like think about it intuitively.
The responder would be worse off than the proposer.
Because I felt it's not fair, right? You give me 1 cent and you keep like 99 cents. And then even if I triple the amount, it's like 3 cents, right? The difference between us is so large, I'm not sending you shit, right? Because I felt it's unfair if I have a Fair-Schmidt model. But if I don't have a Fair-Schmidt model, whatever you offer to me, I should gladly accept, right? So in this case, if let me just do it. So the money I ultimately have, the money responder ultimately have, and then this thing I just like that, and do this. The money that proposer have. If that amount is less, then I feel, well, I mean, the responder feels pain from inequality. Therefore, no amount of T I will send back will be sent. Right? Is that true? Guys, let's be a little bit more interactive.
I think that should be correct. That if the inequality is, if the responders would be feeling the inequality, they're not going to send anything back. But if it's the proposer who feels the inequality, then there's a possibility to send something back.
Like, yeah. So this is directly reflecting to the pre-existing prompt that we're given. This is standard Fair-Schmidt model, right? When beta is less than 1 and between 0 and 1, right? And alpha is greater than beta of, right? Okay. So what if 3s is greater than 1 minus s? What will happen? So somehow, because of your generosity, now I have so much money. I will reciprocate, right? Because I have more money than you. I will feel pain to see you have so less money, right? I will actually share it with you so we can be equal. So I don't feel the disutility from the inequality, right? So this is the condition we need. The responder will consider to send some amount of T of T to proposer. Yeah. Okay, now we have that inequality. Now we just want to find out what that S amount would be. So the S amount would be 3S greater than 1 minus S. Shift it around. We got 4S greater than 1. S is greater than 1/4. So you have to send 1/4 of your original amount in order for me to even consider to send you any amount of t. Does that make sense?
Does the decision tree factor into this, that node that comes out of it? Because it has the same inequality there, or it could have it. Or is that just a coincidence?
I mean, we can use the decision tree, but we don't have to, because we trying to determine what amount of S that you have to give it to me in order for me to even consider amount of t. Right? We're not touching the t yet because we don't know the amount of t. I think next question, we're supposed to find the actual t value. Well, next question on D. But we don't know the t value yet. But we're just trying to find the amount of S, which is S min, right? So this is S min.
Okay, thank you.
Okay. Is this clear? Or is it like not clear?
Makes sense.
Makes sense? Okay. Please ask me questions. I'm trying to improve. Okay. So we have C. For now, let's assume S is large enough. So we have S is greater than S min. That the responder, right? Responder is R. It's seriously consider how much to send back, right? So we're at the stage that, okay, you give me enough amount of money that I actually feel guilty because this is tripling process. I would rather to give you some tea, right? So oh, okay. So now we are given tea. So we're doing this because we're actually thinking about giving some tea, right? So we'll maximize of t where our utility function would be what? Would be
3s minus t.
What?
3s minus t, minus beta 3s minus t minus 1 minus s plus t.
Right? So this is the utility function that I actually feel guilty of having too much money because you send me enough of S that I'm actually considering give you some T. Okay? So let's simplify. Oh God, algebra. Ew. Wrong, wrong, wrong. Hmm. Hmm. Okay. So you should have max
Can you
T.
explain again why we're using beta here for UR and not alpha again?
Because beta is because I feel guilty that you are poorer than me. Is that correct? We found this condition. I shouldn't draw it too ugly. No, use this color. This is the only condition where we're actually considering giving you any amount of t. If you give me less than S min, I'm gonna give you nothing. Don't even think about the t because you treat me so unfair. I still suffer from the inequality. There's no way I'm gonna give you any amount of t. Unless you give me enough amount of S that I tripled it, and then I'm willing to share with you because I feel bad about me having much more money than you. That's the green condition. This must satisfy in order for me to consider any amount of t to be given to you. Okay. Are we good on C? Okay, let's keep going. D. D is the hardest one. Uh, he's brutal. Uh, okay. Now, solve the responder's utility maximizing problem. This cannot be done by taking first order condition. Instead, rearrange the term in the responder's utility to isolate T. Show that if beta from the responder is high enough that utility gets bigger as T rises. If beta from the responder are small enough, the utility gets smaller as T rises. Based on this, determine the responder's optimum decision at different value of beta from the responder. So how should we set up this? We're trying to find T. Want to find what T amount I would set. If you give me more than S min. Good answer, bad answer, it's all answers. Anyone want to try?
Factor the utility function for t.
Right.
So you want t in terms of b, basically. If I'm saying that correctly.
T in terms of B
Yeah.
or in terms of, yeah. But how can we find B?
but you can't find B, but you can find the relationship between T and utility and B and utility, and then use that to to determine what the question is asking.
But we need to find B, right? Because there's one unknown, two unknown, three unknown. Okay, so you basically just solve this Lagrange. And you will get max of T. We're maxing T. What's maxing T means? What is this? What is this Lagrange one like actually doing? Like the intuition of this Lagrange. Why are we taking Lagrange of this utility function? Because we're trying to maximize our utility, right? This is the utility function. Utility. And we're maxing our utility by giving amount of T, right? Well, no, we're maxing the amount of T in terms of our utility. Anyway, it's du dt. And then set it equal to 0, which is -1, negative beta 4. No. Hey, yikes. I shouldn't do this. Okay, fine. Since my algebra it's so bad, I'm just gonna distribute it. That looks right, right? Yeah, that looks right. Okay, so du dt, we got -1 plus 2 beta and set it equal to 0. And we got 2 beta equals 1. Beta equals to 1/2. So can anyone like tell me what beta equals 1/2 means in this case? So who's beta?
Is it if beta is 1/2, you're indifferent from giving T or 0 for T?
Beta equals 1/2, you are indifferent between giving 0 or T?
Yes.
Yeah. Ah. I mean, it is a critical point, right? It is a critical point. Let's see if it is. Let's see if it is. So in my notes, it says, this is the critical point where T is maximized. And if beta is greater than 1/2, I can't even read my own handwriting. This is the only point. Well, I mean, not the only point, but like anything above 1/2, right? So maybe it's not 1 point. The only scenario where utility is maximized by giving any amount of t. Which it means what? The responder will have increase in utility as t increase. So when beta is greater than 1/2, that's the point where by giving more t, I'm actually feel more happier. I feel more happier because I feel it's fair. Does that make sense? So what if we have oh shit, I'm sorry. My coughing is just it's just so bad. What if we have a beta r is equal to 1/2? What happened?
Utility doesn't change from an increase or decrease in t.
Yep. Utility is constant. Is constant. Does not affect effect on increase. Well, that's not effect or whatever on any amount of t. Sorry, my grammar is bad. As long as you get the the intuition. What about like R? No, BR is less than 1/2. What happened?
Utility falls if t goes up.
Can you say that again?
Utility falls if t goes up. T goes up, utility goes down.
T goes up, utility goes down. Yeah, 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 yeah. Yeah, I would say so, right? If beta is negative, then you feel happy that you just didn't give any amount of t to the proposer, right? So in my notes, I wrote that responder doesn't feel guilty. Doesn't feel guilty of inequality. Responder will give t equals to 0. They will not give you any money. No, I mean, responder won't give you any money back, right? From the game. Because I don't feel there's inequality. I don't think it's not fair. I'm naturally, this money is belong to me. Like, bro. Yeah. So when beta of a responder, so this is all responder. So this sub thing is very important because there's a difference between BR and BP. They can be different number. If in an exam it's not a same beta throughout, like it's different number. It's different coefficient. So if you were in an exam, try to write the sub to make sure that you don't get confused. Unless in the question it says like, oh, assume the same beta or whatever. But like always have some identifier because you get confused if there's like so many B floating around. Okay, so are we good with this beta? Okay, so now we have the beta. Now we can just plug it in. So if beta R is greater than 1/2, this is the only way T exists, right? If R is greater than equal or greater than 1/2. Yeah. So can we just plug it in? This is responders. Let's set beta equals to 1. We get 3s minus t minus 1 plus s minus t. Can anyone tell me why I set it equals to 1?
Because beta is between 0 and 1.
Yeah. Yep. And we have 4s minus 2t minus 1 equals 0. And then just isolate more algebra, which I do not know how to do. Ooh, minus 2t. Is that correct? So I move. Okay, yeah. So 2t equals to 4s minus 1. T equals to 4s minus 1 divided by 2. Okay, so let's recap again. I'm just gonna draw the decision tree again for a different beta. Okay, so we have a proposer and we have a responder. proposer can make decision whether or not giving an amount of S or giving an amount of 0. The outcome would be 1, 0. The responder depends on responder's beta. We have 3 outcomes. So responder will giving amount of T and T equals 0 or T equals to anything or it doesn't care. Does not care. Even though this spell doesn't care. But however, okay. So that's all 3 different outcomes of different amount of T. Okay. Are we good on D? So how do we determine, like, how do we interpret this number, the T? So this would be like a piecewise function where T equals to 4S minus 1 over 2 if beta is greater than 1/2. And T equals to indifferent between 4S minus 1 over 2 to 0 if B equals to 0. So 0 if B equals, well, no, less than 1/2. So how do we interpret this T? So T is depend on the amount of S that you set, right? So if you send me some minimum amount, let's say, if you send me, what's our estimate? Do we have an estimate? It's 1/4, right? So we have a 4 times 1/4 minus 1 over 2. Why does this thing look so fishy? Okay, for example, let's do 1/2. See, if I send 1/2, how much would you send me back? If I send 1/2, you will send me exactly 2 minus 1. You will send me 1/2 back. Okay, makes sense, right? S min is S min, right? If we're putting S min, like I'm not gonna send you anything back because that's the equilibrium. If my beta equals to 1/2. Well, I mean, if it's greater than 1/2. Because we're equal. So 1 minus 1/4. This is responder, right? No, proposer. What am I doing? P equals to 3/4. And then I will have a responder. How much responder gets? 3 times 1/4 equals 3/4. Da 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 da. We're perfectly equal, right? Then why am I sending you any amount of T? But if you're sending me more than the S min, I'll start to send you money because I feel bad, which is exactly what this tells us, right? 8 o'clock. Okay. Any question on D? D is really stressful. I know. But yeah. Okay. So let's do E. What's E asking? Now we have a fully mapped out how responder will respond to any given S. We can turn to proposer's decision. Describe in words how they will pick S. Okay, so who want to try this? Just describe in words.
It's conditional on beta responder and on beta proposer.
From the betas from the proposer, yes. And then from what else? I didn't hear the first part.
The beta of the responder and the beta of the proposer will determine
Proposer.
how they will pick S.
Okay, let's.
And then go and then I guess we can go through each case or not.
Does it really depend on proposer's beta though?
It depends if the responder doesn't send anything, the proposer might still get, depending on their beta, might still get inequality aversion, and therefore they might still send money.
Okay. Let me see if I can write out. I think you could be right. It's just like I need to write out the equation. I actually like look at it and then see what it'll look like. I forgot again. Okay, so A is so this is pain from rich. Pain from poor. You guys shouldn't use my broken English in exam. uh okay, so let's build up this model real quick. So 1 minus s, we know that we're giving some amount of s, and then we have, do we have this pain from rich? Does it matter in this case?
No, proposer would never sends more. Well, actually, it could be different this time. Never mind.
You're saying the proposer never send more than certain amount?
If it's not a trust game, they wouldn't. But this is a trust game, so they actually might send more.
Okay, so trust game depends on what? So it depends on whether or not like R is like gonna like giving the money back, right? Yeah.
Yeah, I got to an answer too quickly. I should be more careful.
So like proposer, like think about yourself as a proposer. right? Like you have this friend who is like managing like some kind of like Robinhood secret model account or whatever. And he's telling you that he can triple amount of your investment in 3 weeks, right? So like he's like, okay, you should give me this $1,000, so I will invest it for you. So we have a $3,000 and then we will split. So how do you maximize your return in this case as a proposal?
Give him all the money.
Right. Exactly, right? I'll give them everything if that person is trustworthy. If I'm certain that, well, I mean, not like I'm certain that, but like I know that R is gonna reciprocate, right? So if R has a higher beta, right? He actually felt guilty of taking the money away from me and then just run off and keep all 3,000 in his pocket. He actually, give it back. If his beta is greater than 1/2, then I will give him more money. So he can give me back in returns of T, right? But if I know that the responder is not trustworthy and his beta is like, really wobble, some negative amount, that he takes pleasure of cheating on me and take all my money, then I wouldn't give them anything, right? Yeah. So let's look at this again. Minus beta of P, which is proposer, 1 minus S plus T minus 3S minus T. And this T star are built from the beta from the responder. Right? So if well, if responder have high beta, that will indicate the amount of T that proposer will have in return. Okay. So I am sure you guys already went through the key, perhaps. This is not an easy exam, um, especially the final. I remember I get significantly lower score compared to my midterm. Uh, so be careful on the final and try to practice, and until you get comfortable with Fierschmidt. Also the interpretation of the Fierschmidt. Because question one, it's fairly easy, but it's only D and E. She's like, oh, why? Uh, okay. So any additional questions? I think that will be it for today, though. But if you have a quick question, you can ask. not gonna go over question 1. Maybe tomorrow.
Could you just explain B to B one more time? If that's okay.
2b.
Yeah. Not the whole thing, just what the inequality.
Okay, let's take a look. Okay, so B again. It's trivial when you know that the intuition, right? But it's not trivial if you only look at formula, right? So this question is asking, use a backward induction to predict the outcome under Fair-Schmidt's preference. Suppose the proposer has picked up some value of S, and now responder has a 3S and has to choose amount of T, right? So we know that the responder has to give some amount of T, which is this thing, right? Proposer already give me enough of S that I can start to give T. So what amount of S would that be? That S, like the end result of the whole thing, like we should be equal. We should be evenly split. Like, okay, let me just bring up the thing again for the investment in like some kind of model. Okay. So if I have a 1,000, well, if Zach, you have $1,000, okay, I'm gonna suggest you to invest in some like really funky stuff that I know that is gonna get you 3x in return. Like, in order for me to give you any kickback of T, I felt like it's fair that we're equal, split, right? Because your $1,000, it's like the heaven drop you $1,000. All right. Well, in terms of like this game, right? It's not like you are minus 1,000 or whatever, but you're like actually something drop $1,000. And we both like in the middle and looking at that $1,000. And then you are the proposer. You're looking at that money, and then you are making the decision whether or not you want to give that money to me because I promise you that I will get you some money back. We can split evenly so everyone is fair. Right? So the amount of money that you have to give it to me in order for me to give you anything, it has to be greater than the amount of money that I can get triple back, which is like just this.
So 3S is the responder share, and 1 minus S is the proposer share, and they have to have some kind of, if they're equal, then they'd be indifferent, then the responder being different, so then there's an inequality. And basically they're trying to figure out how how much that gap has to be for them to be equal at that point.
Yeah, only if like in the end we're equal, or I have more money than you, right? If you have a $1,000 and you give me like, let's say you have $900, and you give me $300, and then I 3x it, and then now I have now I have a $900. It's only if this green condition is true that in the end we are equal. or I have more money than you. If I don't have more money than you, then there's no T. I wouldn't
Right.
do anything.
Because then you wouldn't feel any kind of pain necessary to send anything back.
Yeah, I don't feel obligated because I feel like it's fair. Or it's not fair, but I can't do anything with it because this is not like ultimatum game, right?
Right. Okay, I think I kind of get the intuition. Thank you very much. That was very helpful.
Okay. Well, tomorrow, yeah, another session, probably go over question 1, maybe. Also, like open to any other problems that you guys might have. Yeah, I'm gonna try to get the homework grade as soon as possible, but don't count on it. Just try your best to go over the assignment 5 if you can. Okay. Well, that's it for me.
Hey, Andrew, is there another Zoom tomorrow at the same time?
Yeah, same time.
Okay, thanks a lot.
Good night.
Thank you. Good night.